Okay, I think we are live right now. Hello, Sergei. So welcome. So hello, everyone. So we are going to be with Sergei. So he's going to mention about optimizing ABP deployments. So strategy and best practices in Helm and Kubernetes. So Sergei is from Decision Tree Company. So he's going to give an introduction to you himself. So Sergei, so you can share your screen and start your presentation.
Thank you, Tariq, for kind introduction. Hello, everybody. I'm going to share my screen and we will get started. Appreciate your attendance. I know it's well afternoon in many places in the world, so appreciate your patience and I hope we will have a very good time together. Let's start rolling. I'm going to click a share screen button in a second. Here we go. I hope my screen is visible now. So today we are going to focus on our experience with optimizing ABP deployments in various environments, including on-prem, cloud, and various automation options. Let me say a few things about the company I represent. Decision Tree have been working with Volosoft products for more than 5 years now, and we've gained lots of experience in development and production hosting of ABP solutions, as well as ASP.NET Zero. Let's get started. Apologies for that. So as you probably know, ABP framework is a cloud-friendly application development framework, and it can be deployed on various cloud services, including Microsoft Azure, Amazon AWS, and Google Cloud. This is the main subject of the call: how to choose the right environment for you, for your application, and which tools and services is best to use to optimize your production experience and achieve the goals of the application. And we will look at some of the real life examples and case studies. As you probably know, ABP supports two major types of architecture: monolithic architecture, which is fairly simple to get started with and deploy your applications fast. It doesn't require very technical architecture team and knowledge in networking and DevOps best practices. Most of our projects, we start with monolithic architecture, and if needed, we move on to a more complex microservice architecture. Now, by choosing monolithic architecture, it doesn't mean that you have to develop all your code in one big chunky project. ABP supports module-based development for monolithic architecture, and that allows you decoupling of your application in terms of code base into smaller pieces, and that's a very big advantage of ABP framework comparing to out-of-the-box .NET development. So that's important to keep in mind. Now, this is a bit involved slide, so we will get get through it step by step. As I mentioned before, ABP allows us hosting of production payloads on Azure, AWS, and Google Cloud as well. And if we go with the simplest option of monolithic ABP deployment on one of these cloud services, we have to choose it's our recommendation is to choose the native application services for that cloud vendor. For instance, in case you run your payload on Azure, for some reason you decided to use Azure as your cloud provider, it means that you will deploy your user interface on Azure static web application in case it's Angular or any other JavaScript user interface, and you will deploy your web API on application service, which allows you simple deployment of your web API and management and scaling without in-depth knowledge in DevOps. It's very similar experience to good old IaaS based deployments, and that way essentially a development team without in case you don't have dedicated DevOps people, you can definitely manage it with your own existing resources um, and benefit from elasticity and scalability of a cloud this way. Just one word about the option of choosing static web app hosting for Angular front end. The benefit of it is mainly around cost and performance. Azure Static Web App, it's a relatively new option for hosting static user interfaces on Azure. And it has two tiers, free tier and standard tier. And in most of the cases, free tier is good enough for production applications of not very big volumes of users. It means that by choosing static web application hosting versus Azure Application Service, you save hundreds of dollars, if not thousands in some cases, in your production hosting costs. In case you choose authentication server as to be hosted in your as a separate application, so-called tiered template of ABP, you would have to host it as Azure Application Service, and Azure Key Vault service allows you a secure management of configuration in the cloud, in Azure Cloud. Our recommendation of the database on Azure is Azure SQL because of its elasticity, scalability, and affordable price comparing to other options. Similar composition if you decide to go not with Azure but with AWS. We'll use AWS Amplify for static payloads or Elastic Beanstalk for .NET web services. It means Web API authentication server will be running on these Amazon services. Similar to Azure, Amazon allows Amazon RDS, scalable and elastic SQL Server engine. Obviously, if you choose to use MongoDB or PostgreSQL or other databases, you have to choose the appropriate data engine. Amazon also allows its own managed cache, Redis cache. Definitely a recommended option to go with, comparing to hosting Redis on a VM or other ways, and be responsible for stability of this service. The same applies to Azure Key Management Service. And last but not least, Google Cloud again offers comparable elastic managed services for static user interface. Cloud CDN, Google Cloud CDN would be the best choice. For Web API, we will use Google App Engine, and if authentication server is a standalone service, it will have to go to be hosted on Google App Engine. Redis memory cache and databases, the same applies, similar to AWS or Azure, and Google Key Managed Service is the configuration management infrastructure of choice in that case. In case you are, now we will be moving to microservice options, and in this case, again, many companies decide to move to microservice architecture for their own reasons. We will discuss it a little bit later on one of the next slides, but the benefit of ABP framework is that relatively complex architecture of microservices simplified for developments and documented very well, and allows a team without prior experience with microservices get started and make very good progress with microservice architecture on ABP. So, but it's much more complicated infrastructure comparing to monolithic application. And our recommendation in case of microservice architecture, really stick to ABP documentation, and you will be safe that way. In case of microservices, we offer, or we recommend a few ways of deploying this payload. Use microservices for UI and API, and the number of API components for microservice may differ. Some projects have one or two microservices, some others have tens of them, and this is the beauty of microservice. Essentially, microservice architecture allows you unlimited number of microservices being developed and deployed simultaneously, and each one of them can have its own technological stack, and can be scaled separately. If some of the services of your large application require higher load, support of higher load, you can do that on that particular microservice without increasing resources on the rest of the microservices, which don't need such resources, such high level of resources. So basically, you get to choose where you increase your scalability and throughput. ABP framework allows you to deploy microservices on each one of these cloud platforms, and by using the right set of tools, you can basically deploy. You don't have to feel stuck with Azure, AWS, or Google. You can automate your deployments on each one of these platforms simultaneously in case you have to support multiple clouds at the same time. And that's a serious benefit. Let's look at Kubernetes as a tool. And Kubernetes is the go-to platform for complicated deployments which require high level of automation, and it's been around for 10 years now, and it's very mature tool. So no reason to be afraid in case you haven't worked with it. It comes up with lots of benefits. First of them is that you can definitely use the same set of skills and infrastructure in many cloud environments. So you're not being so-called vendor. You being vendor agnostic. If you choose Azure today, you can easily migrate your application to AWS or Google Cloud, depending where you get best performance or cost benefits. It allows high level of automation for your deployment, rollbacks, as well as scaling. You can increase number of units of scale, so-called pods, on Kubernetes cluster easily without impacting your system in production. You don't have to take your system down, upgrade, and then redeploy. It all happens live, and the mission critical applications remain online throughout this type of maintenance and change in configuration. If you are new to Kubernetes, we are encouraging you to visit Pluralsight training about Kubernetes, and also since it's a very popular platform, we encourage you to use any of the online resources you choose to you like more. Okay, and last and not least, forgot to mention that Kubernetes is well integrated with all automation platforms out there. So essentially, if you decide to use Kubernetes for your payloads, if you use Jenkins or Azure DevOps or any other tools, you will have no problems. Kubernetes supported well there. Let's move on. You probably know that Kubernetes introduces higher level of complexity, and a Helm package manager allows simplification and higher level of automation of updates of your production environment. It's not a new tool. It's been around for since the same time as Kubernetes was launched, more or less, and it's been used widely. Was developed by original Kubernetes team, and the key features of Helm is the notion of charts. It's basically a units of deployment, and templates, and the management of dependencies. So essentially, you can deploy multi service application, microservice applications, as well as monolithic applications using Kubernetes and Helm. And very quickly, your DevOps team will feel the benefits of how simple that is. You can also share same charts across different projects. So if you've invested in development of a chart for Redis cache, for example, you can definitely reuse it in all your other projects which use Redis. Same about databases and microservices. Much easier management of updates and rollbacks in production using Helm is it's as simple as running a single command. So definitely a good investment for your DevOps teams. Check out Helms for Kubernetes training on Plural site or any other resource you find useful. Now, there is additional tool involved for automation of typical cloud deployments, and we have some options here in case, like basically each cloud vendor comes with its own infrastructure as a code tool. Microsoft comes with Biceps. Terraforms is the cross-cloud infrastructure as a code infrastructure, and CloudFormation is the infrastructure as a code tool for AWS. In this presentation, we are focusing on Biceps versus Terraform, and somehow in our projects we choose to use Bicep for Azure and AWS CloudFormation for AWS, because these are the tools which best integrated with with their respective cloud platforms. But if your project indeed has to support multiple clouds as deployment infrastructure, using Terraform probably will be a better choice because it can be used on all three options, Google, Amazon, and Azure. So keep that in mind. But if you are focused on only one cloud platform, for example, Azure, in learning and using Bicep probably will be more effective in the long run, because these the Bicep is more optimized for Azure cloud and lots of different supports like IntelliSense and better integration are there, and there are other benefits as well. So just keep it in mind. Let's look at the one of the example of deployment of monolithic ABP on Azure Kubernetes service. What you see on the left side, these are, as you can see, Bicep files, and they defined a Azure cluster automatically, and we execute these files as part of a CI/CD pipeline. On the right side, you can see Helm charts, set of files. They are mostly YAML configurations, which define deployment configurations for all your components of the application. In case of monolithic application, tiered It means authentication server is standalone. You will have Web API authentication server, Blazor, or other UI tier, Redis cache, secrets, database, in this case SQL Server, and DB migrator. So as you can see, even for monolithic option, monolithic architecture, which is a simple relative to microservice, there is a quite a few configurations which needs to be dealt with and automated. So using automation tools is very helpful instead of deploying all these parts manually to same Azure or VM. It makes a lot of sense investing in deployment automation and DevOps practice. Okay, let's move on. We are getting to the end of this talk, and let's talk about our experience and recommendations. Choosing the right stack for your production deployments is very, very important, and it will determine how much you pay for production subscription, production environment, and what would be the performance of that production environment. So it's as critical as discussing various architectural aspects of your solution. It's very important to include considerations of production environment in very early stages of your software development cycle. ABP framework offers you a lot of flexibility using monolithic or microservice templates. And essentially, it allows you all the options for deployment in on-prem and cloud, and it's a choice, and making the right choice is crucial depending on what you want to achieve. Sorry about that. We highly recommend to start with monolithic application if there is no clear need for microservice. And we talked about microservice, in which cases microservice would be the right choice for you. Majority of our project, we start from monolithic with modules, and that way we keep the monolithic system decoupled enough, and later on, if needed, we can always migrate monolithic solution with modules to microservice one, and that way we complicate our solution as needed. In our case, we always automate our workloads with Kubernetes Helm charts in one of the cloud environments, being Azure, Google, or AWS, and we use Kubernetes workloads even in monolithic architecture. And this is a good investment in our case, in case we'll need to move to microservice in future. That's all I had to share today. Thank you so much for spending the time with us, and I will be happy to answer any questions.
Thanks, Sergei. So I'm going to check the chat right now. if I see any question and answer. Do you see it any? Because
No,
2 minutes
I don't
ago
see.
I went offline somehow, then I came
Mhm.
back. So I believe I didn't miss anything.
Yeah, I
Okay,
see some in the chat. Oh, that's okay. I see that these are
these
yeah
are the
from
hellos.
page. Yeah, yeah,
Okay,
yeah,
guys. So no worries. So if you have any question marks, right, comes after,
yep.
even after this thing,
Mhm.
presentation, feel
Yeah,
free to contact Sergei via info@decision3.tech. So
yep,
thanks, Sergei, for your presentation. So
yep.
see you
My
in the
pleasure,
next,
guys. Yeah,
see you in the
thank you
next
so much.
conference then.
All right,
Bye
all
bye.
the best. Bye bye.